Hello and Assalamu alaikum. My name is Fakisha, and in this video, we will be discussing some um, assembly programs in ATmega 328P controller. So, first program, first we will see our programs in how those assembly programs work in registers, what happens in backend of the IC and registers. So we will be seeing our program in Proteus and in Atmel Studio. So first, if I open a program in Proteus, so in going in source code, if I see over here, in our this program we have to clear R20 register and add 3 to R20 10 times, and then we have to send the sum to port B and use a zero flag and BRNE. So over here we have used LDI command. So LDI is load data immediate. So first of all, we are loading our data in our 16 register. So this 10 is being loaded, and then we are loading our 0 in our 20 register, and in the third step we are loading 3 in our 21 register. So then we are adding R20 and R21 and storing that sum in R20, and then we are using a decrement of R16, and here we are using BRNE command, that is a branch if not equal to, and it will be again and again calling this sum until our uh, until it reaches R16 reaches 0 um, from 10. So and then at last we will get output at port B in R20 register. So if I build my project, so our building of project has been completed. Now we will be debugging our program. So our code has been compiled successfully. So here you can see all the registers are being displayed and they are in 0. So over here, if I move my first command, so in R16 we will be getting 10. So here is our R16. You can see it is A in hexadecimal, so it is stored 10, and the R20 will store 0 in R20. R20 gets 0 over here, and R21 gets 3. R21 gets 3 in this step. So cycle count is moving one step ahead. So here we are using add R20 and R21 R20. So R20 will be getting 3. So now decrement of this 10 will occur in R16 and it will become 9. In the next step, it becomes 9. So now branch if not equal command will be moving, and this will call the addition, and again this loop will keep on working until our R16 becomes 0. It's now 5, it's 4 now, it's 2, 1, and it's now 0. So R16 becomes 0, R20 becomes 1E, and R21 becomes 03. So this step, port B, R20 gets port B, the output. So in this way, it completes our program. So if we move on to Atmel Studio, so here we have the same program. If I build it over here, so after building, we will be debugging our program. So, so after debugging, we will see the registers. What's this? So these are all the registers. So if you move on to our R16 and R20 and see over here, yes. So from here, I will move step into, and this stores 10 or R16. The similar way it is working like it worked in Proteus. So R21 gets 3, R16 got decrement and become 9, R20 becomes 6, and now the decrement and the increment are working. You can see over here R16 and R20 and R21 how the changes are being made as I move the command step into. So program has ended as our R16 this has become 0. So here we have got another program uh, of assembly in which we can see we have to load port B register 0x55 and complement port B 700 times. So we are starting over here with .org 0. So we are loading data in our 16 register that is 0x55, and then we are outputting that register as port B. On port B we are outputting that R16 register. Then we are loading data 10 in R20 register, and here we have used two loops. First is LDI we are loading R70 in R21, and then we are using complement R16. After that, we are again outputting the port B, that is R16, and then decrementing in R21 register. Uh, After that, we have BRNE, that is uh, checking the zeroth flag. So that is calling loop 2, that is complement R16, and then we're decrementing R20 in the next step, and then we are calling the loop 1 by using BRNE. So if I debug my program, so here we have got all the registers, and if we start, so in the first cycle, we will see that R16 gets 55, and then this is outputted on port B, and then you can see R20 gets 10, that is A in hexadecimal, and then we have R2146 stored on that. Okay, then the next step, we have double layered R16. So next we are on cycle 10. Now R16 has become 55. R21 has become 44. Now R16 becomes double A. R21 is in decrement 43. R16 55 again. R21 42. And this way R21 is getting decremented as the cycle moves and loops are called again and again. So this will keep on moving until R21 becomes 0. So R21 has become now 9 and our cycle number is 317. So R21 has become now 0. So as it becomes 0, now we will move on VRNA loop 1, and now decrement in R20 register will has started, and this cycle keeps moving on and on again and again, and it has multiple cycles. So if we see our that program in simulation, so these are the ports that have got active on output, as we have outputted the port B. So these are some of the ports that became active and giving the output. So now we will move on towards Atmel Studio. So here in Atmel Studio, I have already built my program. Now I will debug it. Uh, debug has been completed. Now we will move on processor status. So in a similar way, we can see if I move this on R16, R16 got 55, R20 got A, R21 got 46. In a similar way, it will keep on decrementing. R21 and then R20 and then again R21, and this will be a great cycle. So in this program, this is the next program, we have to determine if RAM location 0 cross 200 contain the value 0, and if so, put 0 cross 55 into it. So we have starting with over here my location. So first we have made my location, my local variable is equal to 0 cross 200, and then we are using LDS command, that is load direct from data space. So we are loading direct from data space and giving input and giving my location into R30 register. So then we are using TST, and then we are using R30 into it. Then we are using again BRNE command and uh, calling the next function over here. And in next we have jump next. This will call again and again. So then LDI R30 has 0 cos 55. So this first checks if 0, and If it's 0, then we will put 055 in R30, and this is the SDS my location. So if I run this, you can see that you will get 2. We've got 55 in R30. So it's calling jump. So over here it remains on jump next. So if we have to confirm this, we'll go into Atmel Studio and see that if we are getting the same result in R30 over here. So if I move over here at 55 in R30 and same, it remains 55 because in R30 we got 0, and if it gets 0, so LDI uploads the data, loads the data 55 in R30 register. So that was from the assembly language in this video. Uh, Thank you very much for watching this video.